So displaying categorical data. After this lesson, you should be able to make and interpret a bar chart or a pie chart, compare distributions of categorical data with charts, and identify what makes some graphs of categorical data deceptive. We're going to talk about how to be deceptive today. All right, so in the previous lesson yesterday, we learned how to summarize data using frequency tables. A frequency table or a relative frequency table summarizes a variable's distribution with numbers. What was the difference between a frequency table and a relative frequency table?
One was like a percent or like a decimal.
Perfect. One of them was percent or decimal. Which one showed the percent or decimals?
Relative.
The relative. Very good. Relative is percent or decimal. So here we have the current population survey conducted by the U.S. Census Bureau, collected data on the highest education level achieved by U.S. 25 to 34-year-olds in 2018. This relative frequency table summarizes the data, so that's relative because it's in percents, and we've got our different categories here. So what we're going to do is we're going to display this data, and in order to display this data, we're going to make either a bar chart or a pie chart because it's categorical. So when you guys are trying to display categorical data, you're going to want to use either a bar chart or a pie chart. Those are going to be your go-tos for categorical data. All right, so what is a bar chart? We'll talk about a bar chart first of all. You guys have seen them before, yeah? What is a bar chart? Y'all can be super obvious with this one. It's a chart with bars. Man, that was awesome. That's exactly right. It is a chart with bars. So a bar chart, it is going to show each category with a bar. The heights of the bars show the frequency or the relative frequency. So a bar chart can actually have percents or counts. It can be either one. So bar chart's going to show each category as a bar. The height is either the frequency or the relative frequency. So your y-axis can either be counts or frequencies, or it can be percentages. This is an example of a bar chart with that particular data that we were looking up at the top of the page. So basically, if we take each of these percentages and we just make it into a bar, there's my bar chart. All right, super easy. And whoops. And so basically, we just take the 7.6, blah, 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 blah. You got it, right? Easy, right? Here's my question for you guys. Does that bar chart have to be in that particular order from left to right there? Not necessarily. So bar charts, there's really not an order they have to go in. All right, categorical data, I can put the data here in any order that I want to. Now, it makes sense to kind of put it in the order that it's in here on the chart, but I could technically put it in any order. But here's what I do need to make sure I remember. Bar charts are for categorical variables. I'm not going to use a bar chart for quantitative data. I'm going to use some other chart that we'll talk about later. Bar charts are for categorical variables. Cool? Cool. Pie chart. You guys ever seen a pie chart before? All of a sudden everyone wants pizza, right? So a pie chart is going to show each category as a slice of the pie, if you will. The area of the slices are proportional to the category frequencies or relative frequencies. Now, I'm going to tell you guys a little bit of a secret about a pie chart. Most pie charts are going to use relative frequencies. Most pie charts are going to be in percentages, and it's going to be percentages up to 100%. So we really like pie charts to show us percentages because that makes sense in our brain when we're looking at the circle. Can a pie chart be in counts or frequencies? Yes, it can, but that usually doesn't kind of equate in our brain to what we're kind of looking at, which is 100% of a pie or a circle. So most of the time your pie charts are going to be in percentages. Do you guys have any questions about what a pie chart or a bar chart looks like? I would guess not, because you've seen these since you were in first grade maybe. It's been a long time since you've been working with these, so. Oh, come on, you stupid. All right, so would students rather be happy or rich? You guys remember that question from yesterday? We had happy, rich, healthy, and famous. So here's that frequency table from yesterday that we had. And so we're going to make a bar chart to display the data, and then we're going to describe what we see. So here we go. Here's step 1. We're going to draw and label our axes. Whoops, that went too far, didn't it? Let me go back. Step 1 is we're going to draw and label our axes. There we go. So on the y-axis, we're going to have the number of students. On the x-axis, we're going to have our preferred status. If you go ahead and label the axis, that's cool. Just be sure you leave enough room that you can make the scale on each side that you would need. So we're just basically drawing and labeling our axis first. We've got number of students, and we've got our preferred status. Now, this bar chart we are making in frequencies, so number of students. And so we're not going to have to transform this into percentages for this one. All right, the next thing that we'll do is we will scale the axis. So on the bottom, on the x-axis, we just have our preferred statuses. We just have our categories. So famous, happy, healthy, and rich. On the y-axis, we can just go by fives. The highest number here was 21, so the highest we can go to 25. So we can do 5, 10, 15, 20, and 25. That's easy enough. And then, obviously, our final step is we draw the bars to the particular height that they belong. So famous was up to 7, so you kind of estimate where 7 is. And then happy was up to 21, healthy was up to 4, and rich was up to 8. And then we have drawn our bar chart. So for this one, our bars don't have to touch. Usually bar charts, they don't touch between the categories, and so we have our bar chart. Do you guys have any questions on how to make a bar chart? Yes, ma'am.
How did you know to put preferred status on the x-axis?
So we're always going to put our categories on the x-axis, and on the y-axis is going to be either our frequencies or our percentages. It's either frequency or percentage, so that tells us how tall we want to make the bar. So yeah, the particular categories go on the x-axis always. Any other questions about this bar chart? All right, so I want you guys to discuss with your group. Just tell me what you see. What does this bar chart help you see? This should be like really quick, 30 seconds. Tell your group something that you notice about a bar chart. Go. All right, you guys, somebody tell me something that you noticed about this bar chart or something that you said.
Happy's the highest.
Yeah, happy's the highest. It's easy to see that now. Yep. What else? Anything else?
Bars.
Huh?
Bars.
You see bars. That's right. Yeah, I see bars. Mad bars. This bar chart is spitting some bars. I know. It's a bad joke. It's fine. All right, we'll move on. Okay, cool. Yeah, there's some things you could have said. More than half of the students would rather be happy than any of the others. Blah, blah, blah. Yeah, cool. All right, displaying categorical data with a pie chart. This is your pie chart. I'm not going to make you guys turn these into percentages. We kind of already did that for you. So the percent that said happy, we saw that yesterday. It's 52.5%. Healthy was 10%. Rich was 20%. And famous is 17.5%. You guys just have to estimate the percentages. You don't have to have a protractor and try to get the angle or any of that stuff, right? You guys know what 25% of a pie looks like. So, you just kind of estimate that. You know what 50% is. So, happy is a little bit more than half. So you just got to estimate. All right, so a pie chart is when you want to emphasize each category's relation to the whole. Here's the big idea, though, the big caution. A pie chart must include all categories that make up the whole, meaning sometimes you're going to have to add an other category in some settings. So here's what I mean. If I were to ask you guys, what is your favorite coffee place, Dunkin' or Starbucks, right? So here's the thing. You guys all answered either Dunkin' or Starbucks, but some of you said neither. And so I can't just be like, okay, well, it was kind of like this with Dunkin' or Starbucks. I have to make sure that I have an other category for those who maybe have said neither, or maybe somebody was like, I don't like either of those. I like that new place. What's that new place? Something Brothers? Yeah, Dutch Bros, right? So I have to account for anything that might be other. So big thing is make sure that a pie chart you include all categories, and you might have to have an other category. So make sure that your pie chart you have everything included that could be included. A bar chart can also be used to compare the distributions of a categorical variable in two or more groups. This is a fictional data set of females versus males and their favorite ice cream flavor. Maybe that'll be our question tomorrow. So here's the deal. We can use this to compare them. What do you guys notice about this data? What would you say if I gave you this and said, tell me something about this data? Way more females answered than males. How did you know that?
Because female bars are taller.
Yeah, all of the female bars are taller. And if I look, a quick little look at the y-axis tells me that this is frequencies. So guys, look, there were 12 females that said chocolate, which is more than all the males combined. All right, so to say that females like chocolate more would not necessarily be true if I'm just looking at this one. All right, so I have to be a little careful on that. So if I look at this, I notice that there are far more females than males. But if I change these to percentages, if I use a relative frequency, which is going to be a good idea when I'm trying to compare groups, especially when they have different sizes. If you are using relative frequencies, it's a good idea to do that when you are having different sizes. So now the female chocolate and the male chocolate isn't as big of a difference, right? So it looks like males and females kind of prefer chocolate in general. However, I can now see that the males prefer vanilla more than the females. Okay, does that make sense? So different sample sizes, we want to make sure that we have it in percentages. All right, moving on. Superpowers. Do you guys want some superpowers? Excuse me. A random sample of 200 children ages 9 to 17 from the United Kingdom was selected from an international website's online survey. The sex of each student was recorded along with which superpower they would most like to have. The side-by-side bar chart shows the percent of males and females who chose each superpower. So here's what I want you guys to do. I want you to compare the distributions of superpower preference for the males versus the females. In your groups, I want you to come up with two comparisons between the males and the females for what you see here. It can be anything that you notice, but compare the males versus the females and their superpower choice. Come up with 2 per group. Cool? Do it. All right, somebody give me a comparison statement right here. Anybody?
Oh, we noticed that the females would rather have, most of them would rather have telepathy, and from the males, they'd rather have freeze time.
Okay, so for the females, the highest percent was telepathy, but for the males, the highest percent was freeze time. Okay, very good. How about back here in the middle? Give me one of y'all's.
Women chose telepathy to play more often than men.
Okay, women chose telepathy more often than men. Okay, very good. Back here.
Females want to fly more than males, and males want to freeze time more than females.
Okay, perfect. Females want to fly more than males, and males want to freeze time more than females. Okay, cool. How about over here?
Both invisibilities are matching.
Ah, good. Both of them chose invisibility at the same percentage. Very good. Back here.
The highest bar for females is the lowest bar for males.
Highest bar for females was the lowest bar for males. Nice, nice. And then over here.
I think all of it pretty much chosen, but yeah, the desire to be invisible is pretty much the same.
Perfect, perfect. Very good. So I really love what you guys just did there. You did a fantastic job comparing. When you compare, that means that you literally need to link them together, males versus females. And you got, every single one of you did that perfectly. So that's one thing I want to make sure you guys notate here for comparing. Anytime you're comparing, you need to make sure that you discuss both of them to link them together, okay? You guys did a fantastic job with that. So comparing males versus females, I would not just say females' lowest was super strength. Well, that doesn't compare the females to the males. So just make sure you guys do exactly what you just did. Cool? Cool. It's also possible that we could do each superpower together and then color code for the males and the females. And so on this one, we've kind of rearranged the way that the data is displayed, but we have still a color-coded key that tells us which one is which, so versus males versus females. So one thing here that I want you guys to make sure you notate or pay attention to is, however you have it, make sure you include a key, okay? Include a key that tells which one is which, especially when you've got 2 different variables going on. All right, so we had gender and we had which superpower. Make sure we know which one is which. Make sense? Perfect. All right, we're going to talk about how to make some bad graphs. So here is good and bad graphs. It is really tempting to make something called a pictogram. A pictogram is these graphs that have these cool pictures, right? Like ice cream flavor, like let's make them into ice cream cones, right? Well, here's the problem with a pictograph. It's a bad idea. Don't do it. It's really tempting to make pictures or to make special 3D effects, but don't do it. Here's why. Our eyes are trained to look at a graph and make an assumption or a discernment about it very quickly. All right, our brains want to do quick assessments. And when we do that, our eyes look at this graph and it reacts to the area. All right, that includes the width and the height and the shape and all of that stuff. So here's the deal. With this graph on the left here with the ice cream cones, we are looking at this chocolate and it looks really big compared to this vanilla because the width of it at the top here is bigger than the width over here. And strawberry looks like it's just like a little stepchild that nobody even cares about, right? But over here, it's not really that big of a difference when our widths are the same. So we're going to want to make sure that when we have a graph, our eyes are going to be reacting to the area. Our eyes are going to be reacting to the area of the bars as well as their height. And when all the bars have the same width, then the area is proportionate only to the height, and then we are getting the right impression about the quantities. So when you guys are making your bar charts, make sure your widths are as close to as possible to the same width. Make sense? So let's look at a couple of examples here. All right, so Harris Interactive asked adults from several countries if they like to shop for new clothes. The percent of adults in the United States, England, and China who said that they like to shop for new clothes is shown in the table. Here's a clever graph. We're going to use the flags from each of these countries instead of just the bars. Why is this misleading?
Because like China is like massive.
Yeah, China looks massive here. And again, if I look at the width of the flag for China, the width of that is way bigger than well, for sure, way bigger than the United States. That makes China look 4 times as big as the United States. I mean, I could fit 4 of these U.S. flags in this China flag here. But there's only a difference of 40%. So it's only double, but it looks 4 times. So the big thing here is, although the heights of the pictures are accurate, our eyes are responding to the width. So again, we don't want to have different widths. So why is this misleading? Because our widths are different. Okay? Look at the bottom chart then. What's going on here? So we fixed the width. Why is this one deceptive? So kind of look at that graph for a second. Still a little bit deceptive here. Why? Why is this one deceptive?
Started at 30.
Perfect. My y-axis here is starting at 30, and so that makes the United States looks like it has barely any, but it has 40%, right? And so now China, again, looks like it is 4 times as tall as the United States, but really it's only double. It's just because I cut off that bottom 30%. So we always want to make sure that we're starting our y-axis at 0. Okay, so let's start our y-axis at 0. So a couple of cautions here. Beware of pictographs and watch your scales. Beware of pictographs and watch your scales. What questions do you guys have about bar charts, pie graphs, or how to make a bad graph? Cool. All right, so for your application today, we're going to be looking at a cell phone problem. So on our cell phone problem, we have the Pew Research Center asked a random sample of 1,502 U.S. adults about their cell phone ownership. The frequency table summarizes the responses. We had 73 that said none, they don't have a cell phone. We had 212 that said they had a cell phone, but it's not a smartphone, maybe a flip phone. And then 1,217 said smartphone. So I want you guys to make a bar chart that displays this distribution of phone ownership among all 1,502 people in the sample. Describe what you see. And then you are going to do a you're going to look at number 2, the side-by-side bar chart is going to show with age groups. And then you're going to, again, compare the distributions. Just make 1 or 2 notes about what you see there. All right? So I'm going to give you guys about, 4 or 5 minutes to do that. And then we will look and see how you did. All right, so let's look at these answers. We needed to make a bar chart of this data and then describe what we see. So here's one answer. I will say you guys could have done this in a couple of different ways. You could have had, maybe you turned those frequencies into percentages. That's totally fine. You could have kind of done this in a different order. Maybe you put smartphone first. But there's a couple of different ways to do this. But here is one option. And then for describing what we see, basically probably most people are going to state something about how there's not very many that have no cell phones, or that there's a lot of people that have cell phones, or smartphones. All right, so that's that one. The next one is All right, so here's a side-by-side bar chart, and we were supposed to compare the distributions. So again, answers can very much vary. Here's just one option. If you talk about the older the age group, the smaller the percentage that own a smartphone. So as we go from left to right, youngest to oldest, we are decreasing in the amount of smartphones. We are increasing in the amount of no cell phones. So those were some things you could have said there. So make sure that when you're talking about comparing, you're talking about all of the groups as a whole. So like you're comparing, when you say that the older you get, the lower the percent of smartphone, then that is comparing. You're talking about all of them at the same time. So those are just some options. Again, those answers are going to vary. Good job.